Section 3.6 Hyperbolas. All right, so as long as I don't change my mind in the future, this is the last of our conic sections we're going to cover. So we covered ellipses, we're covering hyperbolas. Circles are something you should have covered in a previous class. The only other one is parabolas, which you've also seen in a pre-calc 1 class. Um, Hyperbolas are the last one that you haven't seen. So hyperbolas, they look a little bit like this. It's like a double-sided, almost parabola-looking shape. You know what? Why don't I pull it up on Desmos? Let me pause this. All right, so these are some graphs that I've made on Desmos, some hyperbolas. So what I want to show you, the hyperbola itself. Let me get rid of all these. There we go. The hyperbola itself is this shape right here. So I'm going to zoom out real far. So like the farther you zoom out, the more like an X it looks. And then when I zoom in, it gets more of that parabola type shape. Now, you'll notice that because it starts to look like an X, right, as we get further and further out, what it's actually doing is having asymptotic behavior. So it's getting really, really close to these asymptotes. Whoa, if we scroll out, you can see, whoa, it looks like it's like almost on them. But if you were to, I don't know, zoom in way down here, you would see that it never really touches that asymptote. I don't know if you can hear me scrolling on my mouse, but I'm furious scrolling. All right. So these asymptotes, you saw that little box, right, that I had there. These little asymptotes we get from making a little box in between these two parts of the hyperbola, and the opposite corners, when you connect them, they make these asymptotes. So I just kind of wanted to show you a zoom out view of what you're looking at here. And I have a horizontal one over here too. And I spent a lot of time doing these. Please appreciate them. Let me really quickly make that draggable. All right. So you'll notice I have these little pink vertices labeled here, and I'll go back to the image and we'll talk more about it. Hyperbolas have vertices the same way that ellipses do. And I can kind of like drag this guy out a little bit, in a little bit. So this hyperbola shape can get like really skinny. It can get like really wide. And it's not a parabola again. A parabola shape, to be very clear, a parabola shape would be y equals x squared. So you can see the difference, this red shape here. That's a parabola. So it's not really making a parabola shape. It's making a parabola-esque shape is what it's doing. Okay. So where did Zoom go? There is Zoom. Okay. Um, so these hyperbolas here, we have an equation that looks awfully similar to the equation we had for the standard form of an ellipse. I'm going to scroll down to the ellipse one. So here's what we had for ellipses. Um, Notice two big differences. So one, with the ellipses, it was always x first and then y. And a was always the bigger number. Sometimes a was in front, say under the x, sometimes it was under the y. It was just whatever the bigger number was. And then there was a plus sign in between these. And then the right side is 1. If you look over here, right side is still 1. Instead of a plus between them, there is a minus. There's a minus between them. And then you'll notice that a squared always comes first, b squared always comes second. The thing that's changing is y is in front here and it's in back here. And for the x's, it's in back there, but it's in front here. So with parabolas, or not parabolas, hyperbolas, a few things. A is not necessarily bigger than b in hyperbolas. A doesn't need to be bigger than b for hyperbolas. They just have to be both greater than 0. So they both have to be positive. A squared is always going to be the number under the first term, the variable that comes first. The center comes straight from this the same way that it does from ellipses. So from ellipses, remember we had h comma k as the center, and you got it from, the h and the k and the x and the y. The only thing you need to be kind of careful of, notice x and h always stay together and y and k always stay together. So if I were to have I don't know, I'm just gonna like write an 8 and like a 5. Um, the center for this guy here would be 8 comma 5. But if I have an 8 here and a 5 here, the H part, the first coordinate, the X coordinate of the center always comes from the X part. So it would be the reverse of what you think the center would be. It would be 5 comma 8 for this one because the X coordinate comes from the X and the Y coordinate comes from the Y. And we're used to the X always coming first, but they're flippity flopped in this one over here. Just kind of a quick note there. Um, all right, so we have a left and right opening hyperbola. We say that it has a horizontal transverse axis. So you can kind of like imagine like horizontally, it's like opening up over a horizontal axis. I'm gonna make a note here, opens left slash right. So when X comes first, it opens left, the hyperbola opens left and right. The vertices are the places where, like, if you thought of a parabola, where the vertex of a parabola is, it's kind of that same idea here for the hyperbolas. If I say hyperbole, you're going to have to excuse me. The words are too similar. Um, so the distance between the vertex and the center is still A, just like it was with the ellipses. The distance between the center and the foci, that's going to be C, just like it was with ellipses. It's the same over here. Um, the new value here is B, and B helps us make this little rectangle here. The rectangle helps us plot the asymptotes. So the B value is no longer it's not about a covertex, it's about making this rectangle here so that we can draw those asymptotes in. Otherwise, if without those asymptotes, we don't know how wide this thing is going to be or how to even draw it. Um, on the other side here, when Y comes first, then we say we have a vertical transverse axis. So you can imagine this thing is like opening up over a vertical axis. So if Y comes first, this opens up slash down. The hyperbola opens up slash down, which is nice, right? Because like the y-axis goes up and down, and then the x-axis goes left to right. So if x comes first, it opens left and right. If y comes first, it opens up and down. Center is at h comma k. Vertices. The foci. Notice that the foci are being cradled by that hyperbola. So the foci will never be in here. They'll never be within this rectangle. Foci are always going to be, oh, just little cradled and right there outside of the vertex. So it's like past the vertex. Same thing over here. The A value is always the distance between the center and the vertex. The vertices and the foci are always going to be either up and down from each other if it's a vertical transverse axis, or left and right from each other if it is a horizontal transverse axis. These lines right here, um, you'll notice that they have almost the same but different slopes. So for maybe I'll highlight that a slight bit differently here. Um, B is the numerator of the slope for the horizontal, and it's the denominator for the vertical. And then A is it swaps, right? B over A for this, A over B for this. What's really happening if we kind of just like zoom in and just think about the line, this line here, that's the only line I want you to think of. So you have a point on the line, right? I'll use purple. You have a point on the line right here, and I'm just going to say another point on the line. You just need 2 points on a line to find the slope of a line. So we know the slope of the line is rise over run. So how do I get from the first point, from the first point to the second point? Well, I have to go up to here. And how many units is that? Well, that's just B units, right? B is the distance from the center to the top of that rectangle. So B units, that's the rise. And then from here to here, well, that distance is really the same distance as from here to here, which is the center to the vertex. That distance is A. The run equals A. That means that your slope, it's rise over run, it's B over A. So that's what this B over A slope is. H and K, this is just point slope form. This is just a point on the line, and the point we're using is the center because the center works for both of the asymptotic lines. Okay. this is all broken down for you here. Some other quick notes here, which I've really said already. Yep. One thing to note, these formulas here for hyperbolas are different than the ellipse formulas.